Things you will need for the calibration: a milking inflation or anything that seals the nozzle, a container plus a graduated cylinder or spot-on calibrator, a stopwatch, and a paper sheet and a pen.
You can use anything that is available that will seal or fit over the nozzles that you have on your sprayer. What we are using here, what you're looking at, is an old milking inflation that they were going to throw away, and I have taken, for these T-jet caps to make it easier, I've cut a little bit on the end like so. So you can do anything that'll fit. You might find a piece of tubing. You might find a piece of tubing like this one that'll go over the end of the nozzle. But what we have here is something I found that works well, and that is a milking inflation, and I've just cut it in the middle, and just a 90-degree elbow, and put that on, and that kind of keeps the inflation. You could use just the inflation, but that keeps the inflation from bending or kinking when the sprayer is on. And so then what we'll do is turn the sprayer on, and we use this spot-on calibrator because it's a little quicker and easier. And then we will measure flow rate, flow output from each of these, and just go down the sprayer. If you don't have one of these, you can buy these, but if you don't have one, you can also use a container and collect from each one, being careful that you're just collecting from one at a time. If it becomes a problem to collect from one at a time, one nice thing about these inflations and this size tubing is that they will fit together like this, so you could extend it and whatever makes it easy. But if we collect with a container, then we would use a graduated cylinder of some kind, and obviously use a stopwatch and collect into the container for half a minute or a minute, whatever you like to do, and then measure the liquid that's coming out, and then you'll know what is the output in gallons per minute, liters per minute from each nozzle. So I have the meter ready to go. When I turn it on, the line is over gallons per minute, so we're in gallons per minute. So that's 0.52 gallons per minute.
Hi Adam, thank you for joining me. So I have a couple of questions for you. The first one is, after we measure each nozzle's flow rate, what do we do with that information?
Okay, Jose. Well, depending if we're talking about smart guided intelligent spray system, we would go into the computer, and if we go to the menu and then go to settings and then go to the sprayer configuration or configurations in the case of their computer, then we can go to edit and the nozzle setup and literally put in the number for each nozzle that we've collected. Whether or not you take an average of those numbers and put that number in for each line to simplify it, or possibly if there are different size nozzles and different outputs for each nozzle, in your case, then you can literally put that for each individual nozzle into the computer.
And it seems to me that the calibration process is the same if you have an intelligent sprayer system or just a regular air blast sprayer. Is this the case?
Yeah, the calibration is the same, and very simply, the calibration is nothing more than checking the output at the nozzle of the sprayer to make sure that what you expect to be coming out of the nozzles at a certain pressure is actually what you are getting in order to be accurate with your application and your rate that you're expecting for the sprayer to put out. And the two are the same, except for the fact what you do with the information afterwards. And in the case of the intelligent sprayer, obviously you can just take those numbers and put them right into the tablet, right into the program, and the sprayer is going to take those. The program's going to take those numbers into account then to adjust each nozzle accordingly to still give you the desired rate that you have selected. In the case of a conventional sprayer, you would take those numbers and assuming that you don't have any outliers where you've got a plugged nozzle or a nozzle that's very, very worn, you can take those numbers then and calculate what your actual applied chemical rate is versus what you expect. And of course, this involves when you're doing the calibration, you're checking the pressure that the nozzles are set to, the sprayer, and also your travel speed, those type things, to all the variables there to calculate your desired rate versus what is actually being put out. And on top of that, if you find that your output varies greatly or significantly one way or the other from your desired rate, then something has to be adjusted, whether that is to replace the nozzles if they're too worn, in the case that you're getting a much higher output, or you may have to adjust the pressure of your sprayer to compensate, or change the speed, and any of those variables can change to change your rate. It's going to be a decision based on, can I afford to go slower? Is it better to change the nozzles to get back where I need to be? Those kind of things.
Mhm. So I guess that like the key difference relies upon the intelligent sprayer software will automatically use the data that you take to put the amount of water and pesticides or
Yes.
anything that you're spraying as desired.
Yes. And you know, that would, the exception would be in an extreme. Obviously, if you've got a plugged nozzle, or you've got a nozzle that is broken or so worn that it's not anywhere close to the desired or the original output of that nozzle, then those nozzles should be replaced also as well. But the calibration should, the process will inform the operator of any huge outliers like that.
Mm-hmm.
So that's another good thing about the process in itself, is just checking that everything is functioning properly.
Mm-hmm. Okay. I wanted to ask you, what is an ideal pressure to use, like a range?
I don't know if there's really an ideal pressure. It just has to do with the capabilities of your sprayer and what it is that you're doing. I mean, the higher the pressure, the more wear and tear on the sprayer and components.
Mm-hmm.
But also maybe you get a little bit of added benefit from the nozzles and penetration. But in the case of an air blast sprayer, that really doesn't change it a whole lot. you know, you've really got that air there that's affecting the spray output more than the spray output and penetration more so than the pressure. at least that's the way it seems to me. And same thing, you know, as far as ideal, at least in the case of the intelligent sprayer, we have been using, you know, right around 100 psi, because we're limited on the capability of some of the solenoids and what pressure they'll open and close properly. And so that's been right about where we have been spraying, and ideally as low as possible to achieve the rate that you're after.
Okay.
I think that's better for equipment.
So basically, 100 psi is a good pressure considering the type of solenoids that we are using in an intelligent sprayer, right?
Yeah, that's the reason for it, is because they're limited. The solenoids are limited on what pressure they will open. And that can vary also depending on the voltage that's supplied to them too. But
so if anyone watching this video has any further questions, you can find our contact information at the project website, smartapplespray.planpath.iastate.edu. Thank you, Adam, for your time.
all right, thank you, Jose.
We want to acknowledge the project's co-PIs, Dr. Melanie Ivey from Ohio State University, Dr. Heping and Adam Clark from USDA-ARS in Wooster, Ohio, and the PI of this project, Dr. Mark Gleason from Iowa State University. Also to Lianna Wodzicki, graduate student at the Ohio State University, Jose Gonzalez for production and editing from Iowa State University, and to Bill Bauman from Bauman Fruit Farm in Ohio.